Hello, good afternoon, and welcome back to the theatre. We now have a really exciting talk by the wonderful Carl Sargunar, and that's on Umbraco and Docker. So if you could give him a massive welcome to the stage. Carl. We're going to high five.
Hey. Thank you, Emma. Good afternoon, everybody. Welcome to my talk. I am going to be talking about building a containerized CMS application, and it's going to involve a live demo, so please pray to the demo gods, because if it doesn't work, then, I have a fallback video, but it's not as good fun. Okay, let me introduce myself. I am Carl. I've been working with Umbraco for over 10 years now, since the version 4 days back in the very early days of Umbraco. I am a web and cloud technology advocate. I'm a fan of all new tech and cool things to play with, and Docker is one of the things I've been exploring quite a lot recently. Just as a quick show of hands around the audience, can I ask anyone, have you played with Docker? Have you experienced with Docker at all? There's a fair few of you who've have a go with Docker. Okay, well, for the audience who haven't had a look at Docker, let's start with the question, what is Docker? It is, the definition that they give is it's a platform as a service which offers operating system virtualization to deliver software in packages called containers. It's not a new technology. It's been around since 2013 when it was officially launched. It now powers some of the biggest and most scalable applications that are around the world. One way to think about them, to kind of get your head around the concepts, is that they are effectively little virtual machines. That's close, but it's not the entirely accurate picture. One of the caveats before I get into too much detail with this talk is that Docker itself is a massive, massive subject. There's an awful lot that people can learn about it, and I will cover some of the concepts over here. And if you want to know more, I'd be very happy to have a conversation with you later afterwards, or just find me on social media. So, what is the difference between a traditional virtual machine versus Docker? Well, with a traditional virtual machine, what you have is your base machine infrastructure, and then you have typically a hardware-level hypervisor which virtualizes the hardware. So your CPU, the RAM, the storage that you have available to you, the network connectivity, any hardware that's inside your physical machine is virtualized. You can then create guest operating systems on top of your virtual machine, and each of those can have their own operating system. So you could have one VM with Windows, one VM with Linux, one with Mac OS, different flavors of Linux, whatever you want to, because the hardware virtualization level takes care of that. Docker works slightly differently, because Docker doesn't talk directly to the hardware. Docker talks to the host operating, Docker talks to the host operating system. So it essentially virtualizes your calls to the hardware, but it doesn't pass them directly to the hardware. It passes them to the operating system. So when I access hard disk, when I access memory, when I access network through my Docker components, I'm not talking to the hardware directly. I'm talking to the underlying operating system. Now, when I run a Docker host on Linux, that means I have a limitation that I can't run a Windows Docker container on a Linux server, because the underlying operating system isn't there. There isn't the underlying system calls for the Docker runtime to talk to. But because Windows now is shipped with WSL, the Windows subsystem for Linux, you can run both Windows and Linux containers on Docker 10 from Windows 10 onwards, which is really fantastic. So yeah, the way to think about it is the traditional virtual machines, they virtualize the hardware. Docker virtualizes the operating system. Now, one massive benefit that you'll hopefully see with this diagram is that your Docker containers, your Docker applications, they don't need to replicate the operating system. With VMs, I have to install a full operating system onto each of my virtual machines, which massively increases their space. Whereas hopefully you'll see later on, when I'm able to run and create Docker applications for my demo, they'll be much smaller. So, what would you actually get in a container? So if I take the previous diagram and flip it on its side, you've got your container, which starts with your application. That's whatever code you choose to write. And that application runs on top of an image. And that image is one of many that are available from a library. There are publicly available libraries with huge ranges of images. Images can range from a very basic operating system, which just gives you access to the hardware, or it could be an ASP.NET runtime, which will let you host web applications written in .NET 5 and 6. It could be a database server. It could be a RabbitMQ message queue. Whatever your application needs, you'll be able to find a publicly available image. And if you can't find a publicly available image, you can make one yourself. It's rather analogous to NuGet, where you basically can create a package and you can build pieces from existing third-party components out there. So below your image, you have the networking, which, depending on how you want to run your container, whether it's going to be a standalone container, whether it's going to be a container that's part of a larger application, you can configure them in various ways. And I'm not going to go into too much detail about that here, but that in itself is a huge topic. You've then got the native storage that's part of the container, which would be used for your application files. In the case of a web server, you'd use that for your page markup, your JavaScript, your CSS, that kind of thing, compiled binaries. And then you also have external storage, which typically is used where if you've got multiple containers, which in the Umbraco world, where we want to create, for example, a load-balanced web server host, you might have 4 or 5 containers, but they need to share access to the same media library. So that media library could be on external storage, which is shared by all the containers, and that's something we'll see a little later on. The Docker runtime effectively gives us the ability to control and manage all of that, and then that's passed into the underlying host server. So a typical process, if I want to containerize, in quotation marks, an application, is I'll start with the application on my local machine. I'll build the app, and I'll then put wrappers around it. I'll kind of tell the Docker runtime, this is what my application needs to run. These are the ports it needs. These are the networks it needs. These are the underlying images it needs. And that's completely bespoke to you and what you need. You then do whatever tests you want to locally. And then you build what's called a Docker image. And that Docker image is effectively a compiled, fully independent, releasable version of your application. And then that image can be hosted on a container registry. A container registry is basically a big old list of all the either publicly available, if it's a public registry, or private, if it's an internal company registry, of all the images you've created. And once I've pushed my application with a specific version to that registry, I can then deploy that as many times as I want to. And I can just create as many different copies of that as I want to, because it's effectively deploying from a pre-built image. It's like a snapshot in a virtual machine, effectively. Before we dive into a demo, I just wanted to look at kind of what people would traditionally use with Umbraco's earlier versions, version 8, version 7, where you build your user interface, the backend, the API, your business logic. It's all generally fairly tightly coupled. You tend to have to deploy everything at once. It's harder to make big changes and change technology stacks. We've all gone through the pain of upgrading from 7 to 8 at some point in time. Code bases can be large and potentially complex, especially with larger projects. I'm sure everyone's heard of a story where you open a solution and there's your main website project plus 25 other smaller reference projects, and you take 10 minutes to compile those projects. The code bases can potentially be daunting. It can be harder to test the entire code base. Scaling tends to be, you only can scale upwards. You can't scale outwards so easily. Onboarding new members, imagine joining a new team and they have a massive project like that. But, it works. I'm sure we all have huge projects out there where we've done that and it works absolutely fine. And despite the pain, there's nothing wrong with it. It's just a different model. The container model for hosting and building applications is slightly different, where you build pieces depending on what you need. So I might build a piece for my user interface, and that might be a React app or a Vue app, or it might be Blazor, or it might just be a static front end, or it might be a full Umbraco site. I might build an API component or a data component. But each of those pieces is independently deployable and independently testable. They're completely discrete, and they can be completely worked on as and want to. And if I want to replace the API, I can create a new API and publish it in place of the old one without having to touch the UI or the data layer, because they are completely independent. They follow single responsibility. And one of the nicest things is they're not even restricted to the same tech stack. So I can build my UI in whatever language I want to. I can build my database in whatever language I want to. Each of these components can be a separate repository, so you don't have that information overload of opening up a 25-project solution. There are other complexities involved there. So, I'm not going to cover hosting right now today because that's another subject, but there are considerations for how you would host a Docker application and how you'd host there. It's not better. There are different strengths and weaknesses. If you want to build a scalable app, it's more flexible, but there are other considerations that you need to take into account. Okay, before we get into demos, there's a couple of concepts. So a Docker file, that is how you tell the Docker runtime what you want your application to do. So it defines the base image that I'm going to be using. It describes the steps to compile and run your application. It tells the Docker runtime which ports it needs to expose and what networking it needs. And then Docker Compose. Docker Compose is really used where I have more than one component and I want to create an application that consists of, for example, a website, a database, and something else, maybe an API, like in the previous example. And it defines all those various components and the ports which they expose and the storage that they need and the networks that they connect to. They sound very similar, but they do slightly different jobs. And I'll go through an example shortly. In fact, I'll go through an example now. Before I jump to the demo, I just want to look at the tools that you would typically need to try this yourself. In this demo, I'm using the .NET 6 SDK. I'm using RC5 of the Umbraco 10 release. From tomorrow onwards, you'll be able to use the full release. I'm using the biggest tool here is Docker Desktop, which is freely available for small companies. There's a license for larger companies, so I don't think it's a huge amount. I don't know what the license is. And I'm going to use VS Code in this instance, but you can use Visual Studio Full if you wanted to. And that's it. And this is what I plan to hopefully build in this demo. So we're going to start with a very basic site with an Umbraco website and a database, and an external storage of the media and the logs for that Umbraco website. And then I'm going to add to it a few more Umbraco websites so we can create a mini load-balanced environment. And I'm going to add an API to that as a separate container. And to that, I'm going to run a Blazor WebAssembly application, which will use the API to pull content out of the Umbraco API, the Umbraco database. From Cornet's excellent talk earlier, you'll hopefully have got a bit of an understanding about how Blazor WebAssembly works. I'm not going to use Blazor server-side. I'm using the WebAssembly version of Blazor over here. So this is where we start praying to the demo gods. So in this demo, I start with, actually I'm going to delete that because that shouldn't be there. There we go. We're going to start with the database. I don't know if you can see the screen well enough. Hopefully you can. So you're going to start with a database container, and you're going to have inside there the Docker file. So what I'm going to do, there we go. So the first command I'm going to run is docker build image, and this will basically build my database image, and I'm going to give it a tag which will let me identify it in the future and tell it where the actual file is for the image. So I'm going to go to my demo folder, and I'm going to run this Docker image. Now, I've got Docker Desktop running over here. You can see there are no existing containers that are currently active. Ignore that one, that's my development container. But it's not currently running right now, it's grayed out, so you can see that. So I've built the database image from my Docker database, and now I'm going to run it. I'm going to expose it on port 1433 because I don't have SQL Server on this machine already. And I'm going to tell it that I want the data files to live in an external volume so that if for any reason the container is deleted, I don't lose my data files because the database is external to the actual container storage itself. And that's a useful thing to be able to do. So now, hopefully, we'll see there's a running database container. I can connect to that with SQL Server if I wanted to. I'm not going to, but we can. And then I'm now going to look at my website. So my website is essentially an Umbraco 10 website. You'll be able to see from the CS proj, it's using, there we go, 10 RC5. And it's using a starter kit just to basically give you something to look at. I haven't created a lot of custom code inside here. And it's no different to any normal Umbraco 9 or 10 website. So what I'm going to do is I'm now going to build an image for that on my local environment. I'm not publishing these to the cloud or anywhere because that would take a long time. But, oops. What's going on? Failed to read file. Okay, I forgot a step. This is where having notes is handy. My application doesn't have a Docker file inside it, and that's why you've got this error saying couldn't find Docker file. So what I need to do before I can turn my website application into a Docker container, I need to put a Docker file inside there. So I'm going to copy this Docker file into my website, and now I should hopefully be able to run it. All this Docker file is going to tell Docker is I'm going to use the .NET 6 SDK, I'm going to build my website, copy the output to a published folder, and then I'm going to use the .NET 6 ASP.NET runtime image. With this, these are images provided by Microsoft. They're available in the Docker Hub. You can go and inspect them anytime you like. And I'm going to tell Docker that my application is going to live in that folder, and this is the entry point, which is the starting DLL of my application. So hopefully this shouldn't fail now. There we go, right. So this is now building my Docker image. This is compiling the application. It's creating the output for the DLL. It's hopefully, there we go. So it's now built the image, and I have on my local Docker environment, I should be able to see an image which says UMB Web. There we go. So this was created, well, the labels are a little bit old, but ignore that. Okay, so now that we have an image for the website, I can run a website. So I'm going to fire up a website. I'm going to give it a port that I can access it from. And we talked about the shared media and the shared logs. So I'm going to tell Docker that I want my media, my logs held externally from my website. So let's fire that up. And here, hopefully, in my containers, I should be able to see I've got a database and a website. And the database is running on port 1433, website on 8001. And if I open this in a browser, if the demo god's going well, hey, we have a starter kit. This is a single container talking to a single database, so this is a good starting point. But the nice thing about Docker is that creating another container is super quick, or a third and a fourth. So now I have 4 website containers, all of which are serving the same content. So you can hopefully see that doing things like scaling, if I suddenly experience a massive spike of traffic, I'll be able to scale my application super quickly because the code base is the same. My transient files, like my media, they're externally managed, so I don't need those to be internally. I don't need those to be part of my container. So that's the first part of the demo. But now we want to add a second component, which was the API and a Blazor web application. So I'm going to copy this Blazor app into there, and I'm also going to copy this Docker Compose file. So I'm just going to briefly touch on what this Docker Compose file is. So this Docker Compose will tell Docker that I want one instance of the database, I want one instance of the API, I want 2 instances of the web application, and I want one instance of this Blazor application as well. And before I run that, I'm going to clear out my old images. So I'm going to remove all of those. Okay, they're all gone. So there we go. So nothing running right now. And now if I run Docker Compose up, it will, with one command, be able to, if everything goes well, this is the tense moment where does something appear here or not? $14, $15. It's exciting, I can tell. Oh, it's taking a lot longer than it did last time.
While we wait, could you show me the Docker file of the data?
Of the database? Of course. So here we go. So in this instance, I'm using Microsoft SQL Edge as my database. The reason I'm using Edge is Edge runs on both x86 as well as ARM64 machines. And I'm running on Friday a workshop of going through this demo. So if you'd like to come along on Friday, we'll be going through how I built this demo, and you'll be able to replicate this demo. So if you have a Mac, it'll work fine just as well. Yeah, so all I'm doing is telling the Docker instance what I want the SA password to be. These are the environmental variables which will tell SQL Server where to store its database files, its log files, and its backup directories, and the ports to expose, and the entry point for SQL Server. Now, hopefully, yay, right. So the Docker file and Docker Compose is run, and it looks a little bit different because this is not a single container. This is actually an application with 5 containers. It's got the database, it's got the website and website 2, the API, and the Blazor component. So if I open the website, it's just going to be the same starter kit when it wakes up. And whilst that's waking up, I'm also going to open the Blazor application. This is a Blazor WebAssembly app, so this is going to hit an API and pull back. So if I go here, it's got 1, 2, 3, 4 blog articles, and you can see the title and the summaries and so on. So if I go to fetch data, it's going to hit that API endpoint, and hopefully, there we go. So now it's pulled back data from that API, from Umbraco, onto here. So, end of demo, it all worked. Whew. Yes, that's basically what we created. So we created the website, multiple website containers, the API container, WebAssembly container, all in a single repository. And with that last command, you can imagine as a new team member, recreating it as a case of clone the repository, run build, and you're up and running. I don't have anything to install. I have just the Docker, the Docker tools, and everything else is there. So yeah, it's super easy to onboard new developers, install clone repository, build image, away you go. You've got a running site straight from there. One of the big things about Docker is because everything that you compile is built into your image, you reduce, you can never take it away, but you reduce that whole, well, it worked on my machine, because that same image that you're using locally is what you publish to your staging environments and your production environments, exactly the same compiled code. It's got scalability because I can create 4 instances, 5, 6, 7, 20 instances, depending on how quickly you want to scale your application. Portability, because I can deploy the same thing here. I can deploy it to Azure container instances. I can go fully scaled with Azure Kubernetes services and build a whole auto-scalable application with it. And it's also, if you are cloud-centric, it's cloud-agnostic because Docker containers are a standard. They're the open container standard. They can run on Google, they can run on AWS, they can run on anywhere else. You can create your own Docker. Performance versus traditional virtual machines is much, much higher simply because you don't have an operating system. You're basically using your host operating system. You don't have to worry about every single container runs its own layer of operating system above the layer below it. You've got fewer layers to run through. The size of your containers is much smaller as well. And you've also got isolation because you don't have to, you're not dependent on third-party packages. Once your image is built, everything is compiled into that image. So if I have dependencies on third parties or NuGets, I will build those into my image. And once my image is built, it's all already in there in the specific version that I need. Now, where does Docker fit in the whole spectrum of hosting Umbraco? You've got hardcore and Umbraco Cloud, which is more on the platform as a service side, where they take care of the hosting and they take care of the scaling for you. Docker is not that. Docker doesn't give you that out of the box. You have to do a lot of the work for you. Docker sits more on the custom side, but it's not quite the same as cloning an Umbraco repository and hosting it yourself, because we can create images which have a lot of the structured applications inside them already. So it's not, it's more componentized. It's more piecemeal, bringing in the bits that you need. You can create an API and store that in a container. You can create your front end and have that in a separate container. And yeah, as I mentioned earlier, if you want to give it a go, learn how to create images, learn how networks work, persistent storage. On Friday, there is a live workshop where I'll be doing this, and it'll also be online. So come along, sign up. Thank you very much. Thank you.
Just stunning. And the demo gods were on your side, so well done. A massive thank you to Carl. We are going to have an Ask the Speaker session in just a few short minutes, which will be in 10 minutes. So either keep your seat or come back and risk losing it. Come and see us, and any questions you've got for any of the speakers from this block. So we've got the Nikolais, we've got Corne, and we've got Carl. Massive round of applause for everyone. And see you all soon.